Okay, hi everyone. Sorry I'm not here today, but that doesn't mean we can't continue on with some factoring here. Uh, so what we're going to do today is factoring simple trinomials. So we have a trinomial in the form of ax squared plus bx plus c. Okay, so a, b, and c are all constants, so they're all numbers. And then in the case of simple trinomials, specifically a equals 1. Okay, so it's always going to be 1 for simple trinomials. If it's not 1, that's when we're going to have a tricky trinomial, which we're going to talk about on Monday. Okay, so first, let's just remember how we expand. Okay, if we multiply two binomials together, we need to FOIL. So we have x times x, which is x squared. We do the first two together. We do the outside two together. That is 6 times x, which is 6x. Do 4 times x in here, which is 4x. And then 4 times 6 for our last two is 24. We have some light terms in the middle here. Why is that still blue? So it's going to change to green. Okay. Sorry, I'm doing this on my computer. I'm not sure how well this is going to work for the smart notebook, but we'll give it a try. So we have x squared plus 10x plus 24. Okay, and that is how we FOIL, which some people forgot on the quiz. Okay, and then if we have two variables, that's okay. We're just going to follow the same process. X times x gives me x squared. X times 7y will be plus 7x times y, so or 7xy. 5y times 7 or times x is going to be 5xy. And even though I had like y and then multiplied by x, you could go 5yx, but oops, didn't want to do that. Whenever, why is it still, what am I doing? Why do I not have an eraser here? Oh, I think I have the pen permanently on. Sorry about that. I have some minor technical difficulties. Can I make this great? Oh, no, now we have an eraser. What is going on? That's really no, we just won't make a mistake at all for the rest of the lesson. Sorry about that. Okay, x squared. Yeah, we put them in alphabetical order. Okay, and then the last two we'll have plus 35y squared. Okay, simplify the middle two together to get x squared plus 12xy plus 35y squared. This is a little thicker than last time, isn't it? Let's see. It'll change it all. Okay. So notice for both of these, I have a 1 on that x squared. Okay, don't need to write the 1 because it's assumed to be there if it's just x squared, but it would be uh, just 1. Okay, so you can also always rewrite that as a x squared plus bx plus c for simple trinomials. Okay, so how do we factor this? Factoring is the reverse process of distribution or expanding. Okay, so it's the same thing, just opposite. Okay. So if I want to go from x squared, so many expressions in the form of ax squared plus bs plus c, where a equals 1, can be expressed as product of two binomials. So if I have x squared plus 10x plus 24, well, if I want to express that as two binomials, look it up here. I have x squared plus 10x plus 24. So if I see what that's equal to as product of two binomials multiplied together, look at right here. Perfect. So I know that that is x plus 4 times x plus 6, because x squared plus 10x plus 4 is the same thing as x plus 4 times x plus 6. And if I look at that, x squared plus 12y plus 35y squared, look at that guy right here. So that is equal to, I said that everything is equal here, so that's equal to x plus 5y times x plus 7y. X plus 5y times x plus 7y. Okay, so we can see that these two are equal to each other. So if I have this starting point, I can work my way backwards to get to both of these. Okay, but what's the process actually doing that work to get back to go backwards? Well, this is how we work with factoring. Okay, so method of factoring a trinomial, a simple trinomial, is to find two integers with a product of c and a sum of b. Okay, so I'm looking for two numbers here. So if they need to add up to b. It's going to be the product, or sorry, the sum. Let me move this over. Nope. Okay. So this will be my sum, and this will be my product. See, it's the product, okay? So what I need to do is, using those two numbers, I can find out what they're going to factor to, okay? Because if I take 4 plus 6, that equals the b here, 10. And if I take 4 times 6, that equals 24. Okay? Or if I take 5y plus 7y, or it's just 5 times 7, that's going to equal 12. Then if I, or sorry, 5 plus 7 equals 12. 5 times 7 equals 35, my C term. Okay? So what we're going to do here is factor everything and common factor if we can. Okay? So I have x squared plus 5x plus 6. Now, I need my sum to equal what? Does anyone know? Yeah, go ahead, just yell it out. Good job. My sum equals 5, and my product be equal to, that's right, it'll be 6. So there's my sum and my product. Okay, so what two numbers add up to 5 and multiply to 6? So my numbers here are going to be add up to 5, multiply to 6. Anyone got it? Good. Be 2 and 3, because 2 times 3 is 5, and 2, or 2 plus 3 is 5, and 2 times 3 is 6. Okay? So how do I write this in the factored form? Well, remember, we're going to have two binomials. So I need two brackets, two sets of brackets. Now, in the beginning of each, for simple trinomials, this is important just for simples, I'm going to have x for both of them. Okay. And then in the second term of each bracket, I'm going to put each of these numbers. So here I'll have x, and then I'll have 2, and I'm going to say plus 2 because my 2 is positive. And then in this bracket, I'll put the 3, and then I'll say plus 3 because the 3 is positive. Okay, so I have x plus 2 and x plus 3, and that is the factored form of x squared plus 5x plus 6. Okay, so that's it. Now we're done. Now we're done. Please don't FOIL this after because that's just going to take you back to the original answer or to the original question. If you want to check your work, that's fine. But this is the final answer. Please don't FOIL it after. Thanks. Okay, next. I should have kept a little bit more space in between here. Okay, what's the sum going to be? Sum will be 7. Good. And my product needs to be the other number, which is 12. Okay. So if you want, even like before we start doing this, you can set up your brackets. Well, if x with a number and x with another number. Okay. We don't know what the number is yet, but that's okay. We're going to figure them out. So I need two numbers to add up to 7 and multiply to 12. So my numbers are, good job. The numbers are 3 and 4. Okay, because 3 plus 4 gives me 7, and 3 times 4 equals 12. So I just put each of them in here. I have x plus 3 and x plus 4. And that is my final answer. Now, I hear you asking, does it matter the order? Is it okay if I do x plus 4 here and x plus 3 here? Absolutely not. You need to put them. No, I'm kidding. Totally kidding. It doesn't matter the order. Okay, I could have wrote x plus 3 and x plus 4 here. I could have did x plus 3, x plus 2 here. The order of the brackets doesn't matter, but keep the x in the first spot. Okay, so put the x and then the number, x and then the number. Okay, but like if you wrote x plus 3 times x plus 4, or so if you wrote x plus 4 times x plus 3, that's also fine. Okay, last one. Here I have a sum of, and just be careful because this one has a negative, my sum's actually going to be negative 9. Okay, so that negative is attached to the b. So my b value is negative 9, so my sum is going to be negative 9. My product is going to be 20. Okay, that's going to equal, would I put x in the bracket? No, I'm looking at m here, so I'll put m in the bracket. Doesn't matter that it's an m, not an x. Of course it does not. It's just a variable. Okay, so I set up my brackets. I have my sum and product. Let's take a look here. What two numbers add up to negative 9 and multiply to positive 20? So you might say that 5 and 4, or 4 and 5, they multiply to 20, and they would add to positive 9, but they don't add to negative 9. So what can we do? Throw a good old negative onto each of them. So now if I have negative 4 and I add negative 5 to that, it's like I'm subtracting. So I will get negative 9. And then negative 4 times negative 5, negative times negative makes it positive. So I have positive 20. Okay, so in this case, when I put my numbers in, I still have 4, but it's going to be m minus 4 because my 4 is negative, and m minus 5 because the 5 is negative. Okay, this should all be reviewed from grade 10, whether you took the academic or applied class, because we do simple trinomial factoring both of them. Okay, so let's do some more common factoring. So here we go. This time s My sum is going to be -13. My product is -48. Okay. And then I need to find two numbers here and set up my bracket so it equals, sorry, there should be a dot there, equals Z in bracket and another Z in a bracket here. Wonderful. Okay, so what we're looking at here is a sum of -13 and a product of -48. So what two numbers multiply to 48 and are going to add up to -13? Well, straight up, no two numbers will multiply to 48 and add to 13 if they both have the same sign. Okay? But if your product is negative, if your product is negative, you have one positive number and one negative. You need to have one positive and one negative. Okay, in order to get that negative, because even when our sum was negative, a negative times negative got us a positive number. So the only way to multiply two numbers together to get a negative number is if one is positive and one is negative. Okay, so with that in mind, just kind of think about how we can find two numbers that are going to multiply to 48 and make it negative. So we need one positive, one negative number. So when we kind of add them together, in a way, we're subtracting them because I have a positive plus a negative, which is going to be a negative. Like it's going to be subtraction, sorry. Okay. So two numbers. Anyone? No, this one's a bit of a trickier one. I have 3 and 16. 3 times 16 gets me 48. And then in order to make it -13, because my sum's negative, my product's negative, the bigger number is going to be negative. So if I take 3 and I add -16, that's going to be like 3 minus 16, which is 13. -13, sorry. And 3 times -16 is -48. So I get 3, or Z plus 3 because my 3 is positive, and Z minus 16 because the 16 is negative. Okay, wonderful. I have more room for this one. Okay, so now I have x squared minus 15xy uh, plus 54. So this time I have the x and y like I did back in this question. Okay, x squared plus 12xy plus 35y squared. So I have one of each variable, okay, and together they have, or sorry, they're each squared independently, and then they have both of them in the middle term. So let's look at what we did here. Okay, when we expanded it, when we FOILed it, we had an x in the first position of each bracket and a y in the second position of each bracket. So that's how we need to set this one up. Okay, sorry, I'm just going to write S here, P, my numbers. But then when I'm setting up my brackets, I'm going to have x. There's still no number on the x because it's 1. I'm going to have 1x and 1x. But I will have a little space because I'm going to have a y with a number on it. And here I'll have x, little space because I have a y with a number on it. Okay. So I'm going to fill in the blank in a minute. But because I have the x squared and the y squared and the xy in the middle, I'm going to have sum of each. Okay, so my sum is -15. My product is 54. Okay, so now I need two numbers that multiply to 54 and add to negative 15. And anybody got that yet? Think of your 9 times tables. We're going to have 6 times 9 gets me 54. But then 6 plus 9 is positive 15, so I need to make both of these negative in order to get negative 15. So negative 6 times negative 9 is positive 54. Negative 6 plus negative 9 is negative 15. So I'm going to have x minus 6y and x minus 9y. So I still put those numbers into the second spot. They just now have a y with them as well. Okay? Because we had the x squared and the y squared and the xy term. Now, I have a little problem here. All these other ones had a 1 for that first term, but now we have an a. I also have cubed when normally it's been squared. What do I do? Good. Remember, the question said common factor first if possible. So let's look here. All these numbers are even. I can factor out the 2. Realistically, for any simple trinomial I give you, if it's a simple trinomial, but you have a number on it, factor out that number. Okay. So I'll factor out 2, but then they also all have an a term, so I'll factor out 2a from all of them. Okay. So divide all these by 2a, bring my 2a out to the front. That's going to equal 2a times a squared minus 10a plus 9. Okay, so I'm going to do my sum product over here because I ran out of space on the side. So my sum is now, it's not going to be 20. It's going to be what's in the bracket here because this is the only part that I'm actually factoring in here. Okay, so my sum is negative 10. My product is 9. So what multiplies 9 but adds to negative 10? My numbers are negative 1 and negative 9 because negative 1 times negative 9, positive 9. Negative 1 plus negative 9 gets me to negative 10. 2a times x minus 1 times x minus 9. That's 9. Okay. And that's how we do simple trinomial factoring. You can also apply that to some shapes. So a rectangle has an area of x squared plus 4x plus 3 centimeters squared. Okay, so I need to find out the dimensions. So I need to find out the length and width of the rectangle. And then I'll find out the actual dimensions if x equals 2 and the actual area if x equals 2 centimeters. Okay, we're going to start with 2a. Just draw this out. So I have a rectangle here. Okay, I need my length. Don't know that. And I need my width. I don't know that. Okay, but I do know that the area is x squared plus 4x plus 3. I also know that the area of a rectangle is equal to length times width. So I need to get this area to a point where I have something times something else. Okay? Something times something else. Which, if I take a trinomial and I factor it, I get something times something else. I get something times something else. I get something times something else. Okay? So what I'm going to do here is I'm going to factor the area, and then that will give me 2 dimensions that are multiplied by together. Okay? So my sum. What is my sum? My sum is 4. What is my product? My product is 3. Don't know why I'm kind of saying. What are my numbers? 1 times 3 are the only factors of 3, so they better equal 4. 3 plus 1 equals 4. Whew, thank God the question worked. So my area is equal to x plus 1 times x plus 3. Okay, so this is what my area equals. And we also know that area for a rectangle equals length times width. So I could say that this is my length. X plus 1 is my length here. And I'll say this one's the width. So I'm saying that my width is x plus 3. That's a 3. And then because this is a word problem, I want a therefore statement. So therefore, the dimensions, and again, I could have reversed them. I could have said that the length is x plus 3 and the width is x plus 1. It doesn't matter which one you would write on like an assignment or test. I marked both of them right. This is what I'm looking for here. Okay, so therefore the dimensions of the rectangle are as follows. The length is, that doesn't make grammatical sense, but that's okay. It's math, not English. X plus 1 and width. Well, I also wrote off a big slant there. Is x plus 3. 3. It's hard to write this little tablet here. Oh, sorry, that's a colon, not just like a random like drawing. Okay. 2b. I'm now saying that x equals 2. So what are the dimensions if x equals 2? Well, my length is equal to x plus 1. So if x equals 2, I can sub in 2 for x plus 1. Oh, I could have wrote centimeters here, but like when it's in the Patrick form, I don't really want centimeters. I want centimeters for the actual dimensions. So my length equals 3 centimeters. Okay, x plus 2 centimeters. Make sure you include the units here. My width is equal to x plus 3, which is equal to 3 plus 3. So my width is equal to 6 centimeters. So therefore, the actual dimensions are a length of 3 centimeters and a width of 6 centimeters. Last one, 2C. Let's draw some lines so that we're clear on which part belongs to which. Okay. What is the area if x equals 2 centimeters? So now we have a couple of options here on how we can solve this. We could say area equals length times width, which is equal to 3 times 6, and we just found the length and the width. So area equals 18 centimeters squared. You can do it that way. That's probably easier at this point. Or if you want to double check your answer or go back to the original question, we know that the area is x squared plus 4x plus 3. So I could go area equals x squared plus 4x plus 3 and sub in 2 centimeters here. So 2 squared plus 4 times 2 plus 3, that would be equal to 4 plus 8 plus 3. Okay, which equals 15. Why does it equal 15? Oh my goodness. Whoops. I made a mistake, and you're probably yelling at me for the past however many minutes it's been since I noticed that before. I noticed that mistake. I need an eraser because the width is not 6 because x does not equal 3. X was equal to 2, which I did for here, but I think I saw the 3 and the 3 here, and I just got very excited with 3's. X equals 2, which means that my width equals 5 centimeters and 5 centimeters. Okay, so my area will not be 18. It will be 3 times 5, which is 15 centimeters, which is a good thing that we did it this way because it allowed me to double check my answer because 4 plus 8 is 12 plus 3 is 15 centimeters squared. So now we know either way we do it, as long as we do it correctly, random 3, uh, they're both ways give you the same area. Okay, so it doesn't matter which way you do, uh, you get the same answer as long as you do it properly. If you want to do both ways just to double check your work, it might not be a bad idea. Okay, because everyone makes mistakes. Everyone has those days. So therefore, the area is 15 centimeters squared. Okay, so that's it for simple trinomial factoring. There are a couple worksheets there. I like the one with like the code, where you factor the trinomial, then match that up to the letter, and then you put the letter into the actual spot. Why is it going to kick me out of the call? Then you match that up to the letters to kind of decode the message on that one. So I like that one, or you can just do the straight factoring one, whichever you prefer for today. But if you have time to do both, that'd be great. Okay, and then tomorrow we're going to do a little factoring review before your quiz on Monday. Remember, your quiz on Monday is just greatest common factoring, factor by grouping, and this simple trinomial factoring. Okay, so we'll do some more simple trinomial practice tomorrow, and I'll see you then. Have a great day. Bye.